Hi everybody, and welcome to our geometry unit, the start of our geometry unit. So let's get right into it and go over some basic terminology. Okay, so the first thing we're going to look at is a line segment. So let's go here, line segment. All right, and a line segment is, well, it's just what it sounds like. It's a line, hopefully a straight line that you can draw, okay, and that it has two distinct endpoints, and those endpoints have names, and usually we can just say A and B, but you can use any letter to represent the endpoint. So the key thing is for a line segment, there are distinct ends, okay. All right, the next thing we're going to look at is rays. Okay, a ray, on the other hand, has a distinct starting point. So we can label that A, and it keeps going on forever in any direction. Okay, and we can call that other end B. Okay, so again, the difference is there's a distinct starting point, and this actually keeps going until infinity in this direction over here. Okay, the last one we're going to look at in terms of our lines is the line. And the line does not have a start or an end, so we need to put arrows on both ends like this, and we can call this A, B. It doesn't really matter which end is which, because there's no starting or ending point. Okay, sometimes you're going to see these written in short form as A, B like this, with a line on top of it with sort of ends like this. This one you might see A, B written like this with a little arrow on top, and this one down here you might see A, B with with arrows on both sides. Okay. Okay, we can call this this group, we can call these lines. Okay, and the next thing, next terminology we're going to look at are angles. Okay, so angles. Okay, and again, let's look at some basic terminology here. So we have an acute angle, and an example of an acute angle is any angle that has that's less than 90 degrees. So if I were to measure this angle here, okay, it would be less than 90 degrees. Now let's go ahead and label some of these here. So if this was A, B, and C, okay, this angle A here, and you will see it written like this. You might see it as angle A with B and then C in the middle. The B is in the middle because that's where the angle is. So and I'm just going to say so less than 90 degrees, like that. Okay, so that is an acute angle. The next one I want to look at is the right angle, and the right angle is very specific one. It's when we have a 90-degree angle, when our two lines make a 90-degree angle here. And again, if we were to label this here ABC, our angle ABC, BC would have to equal to 90 degrees. So that's a right angle. Okay, the next one is an obtuse angle, and an obtuse angle is more than 90 degrees. So again, let's have our two line segments. Let's try this again, something like that. Actually, that's pretty close to 90, so I'm going to erase that and maybe make it a little wider like that. There we go. So, and again, these can be lines or line segments. It doesn't matter. So this angle here, okay, it has to be greater than 90. So let's label it again, ABC. And again, you don't have to use ABC. I'm just trying to keep it consistent here. So angle ABC has to be greater than 90 degrees for it to be an obtuse angle. But also very important, it has to be less than 180 degrees. So greater than 90, but less than 180 degrees. Okay, and remember, 180 degree angle would just make a straight line. So if I were to start here like this, okay, some basics. Again, this would be maybe like a 45-degree angle. And if I kept going, this would be a 90-degree angle. And if I kept going, if I kept extending this line all the way to here, like that, all right, then that would make a 180-degree angle. And obviously, if I kept going all the way around, that would make a full circle, which would be a 360-degree angle. Okay, so that's the obtuse angle. The next one we're going to look at is the reflex angle. And the reflex angle is sort of the biggest one we're going to be looking at. So let me go ahead and draw one. So if I were to do an angle like this with two lines, the reflex angle would be the one that's measured over here on the opposite side of your acute angle or your obtuse angle. So if this was A, B, and C, okay, angle, the property is, the rule, I should say, is angle A, B, C has to be greater than 180, so greater than 180, but less than 360, but less than 360 degrees. Okay. Okay, now we're going to look at some angle properties, and the first one we're going to look at is complementary angles. So let me go ahead and do an example. Okay, so complementary angles add to 90 degrees. That is the rule here. So if I have angle, let's call it angle P plus angle S. Sorry, if this little line here, that's just a notation for angle. Hopefully you figure that out. So if two angles add to 90 degrees, they're said to be complementary. So let me give you a visual example here. So if I had a right angle like this, okay, and I say that's 90 degrees like this, and then I went ahead and sort of cut that into two pieces, and I said that this here was this angle here was 30 degrees. What would this angle over here be? This one over here, okay? Well, again, if they have to add to 90, so let's call this angle 1 and call this angle 2. Well, angle 1 is 30, angle 2 would have to be 60 degrees. And then if they're complementary angles. So that is the rule for complementary angles. All right, let's look at another angle property, and those are supplementary angles. So supplementary angles add to 180 degrees. So very similar to complementary, except that now they add to 180 degrees. So let's go ahead and let's call them angle. So if I have angle A plus angle B, they're going to add to 180 degrees. So very similar now. The only thing that's you're going to find interesting here is that all supplementary angles, not all, but most, okay, are going to sort of be on a straight line. So if I had a straight line like this, okay, let's call it, TQ, and if I were to make a sort of a cut like this here, draw another angle, another line coming out of it, these two angles here, let's call them angle A and angle B, are going to add to 180 degrees. So if angle A was 60 degrees, then angle B would be 120 degrees over here. So those are supplementary angles. Okay, let's get into some triangles now. And let's look at some terminology for triangles. So the first one we have, the first type of triangle we have is the scalene. Okay, the scalene triangle, the rule here is that all of the angles are different. So if I were to draw a triangle, let me go ahead and draw my best triangle here. Okay, none of these lines are obviously perfectly straight, but you get the picture here. So if I had an angle like this, let me redo this one because this looks like these lines are about the same. So if I had a triangle something like this, the three angles would all be different, as well as the sides. So I'd have a angle 1, call it angle 1, call it angle 2, call it angle 3. We can call the sides A, B, and C. okay, the rule for scaling is that everything's different, okay? There are no two angles or two sides that are the same. Okay, the next angle that we have is an isosceles. The isosceles triangle. Let me just let me go back up a little bit here. If I were to say A, the rule here would be A cannot equal B, cannot equal C, and the same thing for the angles. Angle 1 cannot equal angle 2, cannot equal angle 3. Okay, that would be the official rule there for the scaling triangle. So if we were to look at the isosceles triangle has two sides that are the same. So let me go ahead and do the classic one that's vertical like this, and you're gonna see how you're gonna know if they're the same size is you're gonna see these two lines like this, sort of hash marks across these lines that indicate that those two lines are the same length. So if I were to have A, B, and C here, A, B, and C, A line side A would equal side B. Okay, that would be the rule there. The interesting thing with the isosceles, of course, is that if those two sides are the same, well, their angles, their corresponding angles down here, would also have to be the same. So angle 1 has to equal angle 2. Okay, angle 1 has to equal angle 2. All right, that is the isosceles triangle. Okay, last one we're going to look at is the equilateral triangle. And the equilateral triangle, as we know from the word equal, everything in the equilateral triangle is the same, including all the sides and all the angles. So ABC here, A would equal B would equal C. So those three sides would be the same, and then likewise all the angles would be the same. So angle 1, 2, and 3, angle 1 equals angle 2 equals angle 3, and as you might have known this, that special degree is 60 degrees, because the final thing I'm going to say here, which make triangles very special, is that all the angles, the three angles, add up to 180 degrees. So it doesn't matter what the angles inside are, the angles in a triangle are always going to add up to 180 degrees. So let me go ahead and give you a quick example here. If I had any triangle like this, and I had three angles here, so let me go ahead and mark them. 1, 2, 3. So angle 1 plus angle 2 plus angle 3 have to equal to 180 degrees. So as long as you know 2 out of the 3 angles, you can get the third one, the third angle. For example, if angle 1 was 30 degrees and angle 2 was 40 degrees, or 3, I should say. So if 1 is 30 degrees and we're looking for the second one, and the third one is 40 degrees, and as long as they add up to 180, which they always do, we can use some algebra to quickly calculate that angle 2 is going to equal 110 degrees. Okay, and that makes sense because it looks like it's an obtuse angle, and we know that we probably got it right. Okay, so thanks for watching today. There was a lot to this lesson, so a lot of it is review. However, just keep special attention to all the different terminology, and try not to confuse lines with rays, and isosceles triangles with scaling triangles, and so on, and all these various angles. Okay, so see you guys next time.